So today we are going to be looking at an infinite series, this infinite series that you see on your screen in particular. So the main questions we're going to be asking today is if this infinite series converges or diverges. So as you add up all of these terms in this sequence, does it get bigger and bigger and go towards infinity, or does it converge to a certain number? And then if applicable, meaning, if this is a convergent geometric, then we're going to try and find what the sum of the infinite series is. So the first test that we're going to do is the divergence test, which basically states that if the limit as n goes to infinity of the sequence is not equal to 0, then the series must diverge. But if it is equal to 0, then the test is inconclusive. We can't figure out whether or not it converges or diverges. So we have to find the limit of this sequence right here. The first thing that we're going to do is use exponent rules to separate this denominator into two terms, since 4 to the n minus 1 is equal to 4 to the n times 4 to the negative 1. We can use another exponent rule to say that having 4 to the negative 1 in the denominator is the same thing as having 4 to the 1 in the numerator. And now that we have this limit right here, you can see that as n approaches infinity, as n gets larger and larger, this 4 right here is not going to matter. What is going to matter is these exponents right here. And since the base of this exponent of this n is much bigger, or is bigger than the base of this exponent right here, the denominator of this fraction is going to get bigger faster than the numerator of this fraction, meaning that this limit is going to go towards 0, which means that this test is inconclusive. So we're going to have to do another test. So since I see a 3 to the n here, a 4 to the n, I'm thinking we should try the geometric series test, which means we have to find the common ratio of this. So the definition of a geometric series is that each consecutive term is multiplied by the same common ratio. So if we write out a couple terms, we can figure out whether or not this is geometric, and if it is, we can find the common ratio. So the first term, a sub 1, is going to be 3 to the 1 over 4 to the 1 minus 1, which is 4 to the 0. This is 3 over 1, which is equal to 3. A sub 2 is going to be 3 squared over 4 to the 1, which is 9 over 4. A sub 3 is going to be 3 cubed over 4 squared, which is 27 over 16. And a sub 4 is going to be 3 to the 4 over 4 cubed, which is 81 over 64. And as you can see, each of these is multiplied by a common ratio of 3 over 4. 3 times 3 over 4 is 9 over 4. 9 over 4 times 3 over 4 is 27 over 16, and so on. So this is a geometric series, and we have found that the common ratio is 3 over 4, since each consecutive term is multiplied by 3 over 4. So now that we know the common ratio, we can figure out whether this converges or diverges, because the geometric series test says that if the absolute value of the common ratio is less than 1, then the series will converge. And since the absolute value of 3 over 4 is 3 over 4, which is less than 1, this is a convergent geometric. And since it's a convergent geometric, we know that we can find the infinite sum using the infinite sum formula, which is basically just that the infinite sum equals the first term in the series over 1 minus the common ratio. Now, we already know the first term and the common ratio from when we wrote out the terms. We found the first term, and then we found the common ratio because each term was multiplied. Each consecutive term was multiplied by 3 over 4. So if we plug those into the formula, 3 over 1 minus 3 over 4, 1 minus 3 over 4 is just 1/4. And if you remember, save it, change it, flip it from 6th grade, this is going to be equal to 3 over 1 times 4 over 1, which is 3 over 4, which is 12. So as this, as we add up all the terms in this sequence, the infinite series will get closer and closer to 12. And yeah, that's that.